Cold open. You are on your knees in a garden bed that should not look like this in July. The tomato leaves are curling at the edges, yellow creeping in from the veins outward. The peppers stalled out at 8 inches 3 weeks ago and never moved again. You did everything the seed packet told you to do. You watered on schedule. You bought the fertilizer with the picture of the giant tomato on the front. And still, every single year, something in this dirt is working against you. And you don't know what. Because you have never actually looked at it. Not really looked at it. 2 states away, in a farmhouse kitchen in Elkhart County, Indiana, a man named Amish Bontrager keeps a mason jar of dirt and rainwater on his windowsill, and in 10 minutes, using nothing but that jar, his hands, and a splash of vinegar from the pantry, he can tell you more about a plot of ground than most $180 mail-in lab kits will tell you in 3 weeks. No box, no barcode, no mailing envelope with a return address in Iowa, no login to a website to view your results, just dirt, water, and about 600 years of people who could not afford to guess wrong about what the ground could grow. By the end of this video, you are going to be able to walk into your own backyard, take a small sample of soil, and in under 10 minutes, know its texture, its drainage, its biological life, and a rough read on its pH. All without spending a single dollar or waiting on a single result to arrive in the mail. And I am going to give you the one test at the very end that Amish's grandmother used, one that most modern soil scientists have quietly stopped teaching, because it does not require a kit, a subscription, or a company at all. Why, I even asked. I want to be honest about how I got here, because I was not always someone who trusted dirt over a data sheet. For years, I sent soil samples to a private lab twice a season. $34 a sample, plus shipping, plus the 2 to 3 week wait, plus the follow-up call from a salesperson trying to get me to buy a custom fertilizer blend calibrated to my exact numbers. I did the math on that one spring. 4 beds, 2 samples each, $272 for the season, and at the end of it, the advice I got back was almost identical to what my neighbor's grandfather could have told me by rubbing a pinch of my soil between his fingers. That is the moment I started paying attention to what people were doing before soil testing was an industry. Not because I distrust science. I don't. Universities have done extraordinary work on soil chemistry, and I am going to cite several of them in this video. But somewhere between the laboratory and the homeowner, testing your own ground turned from a basic act of observation into a $700 million a year industry. And most of what that industry sells you can determine yourself, standing in your yard, before your coffee gets cold. The historical receipt. This is not folklore dressed up as fact. Land-grant universities were writing this down over a century ago, before soil testing required a mailing address. Purdue University's agronomy department, which sits less than 60 miles from the Elkhart County settlements I am about to describe, has published extension guidance for decades built almost entirely on the same physical, hands-on assessments Amish farmers have used since they settled that part of Indiana in the 1840s. And in Ohio, the Ohio Agricultural Experiment Station published Bulletin Number 231 in 1911, an entire document devoted to teaching Ohio farmers how to judge soil texture and drainage using nothing but touch, smell, and a jar of water, because at the time that was the only test most farmers would ever have access to. What's remarkable is not that this information existed. It's that it worked well enough that it took almost 100 years, and the rise of a lucrative mail-order testing industry for anyone to stop teaching it. The first test. What your soil actually is. Before you can fix soil, you have to know what kind of soil you're standing on. Most people never do this step. They skip straight to buying a bag of garden soil or a bottle of fertilizer without knowing whether their ground is sand, clay, silt, or something in between. And that single piece of missing information is why so many home gardens fail in exactly the same way every year. Here is how Amish does it and how his father did it before him. Take a clear jar. A mason jar works, a peanut butter jar works, anything with a lid. Fill it about a third of the way with soil dug from 4 to 6 inches down, not just the surface. Add water until the jar is nearly full. Add 1 small pinch of dish soap, which keeps the particles from clumping. Put the lid on, shake it hard for a full minute, and then set it down and do not touch it. This is where most people get impatient and ruin the test. You have to leave it alone. Within the first minute, the heaviest particles, sand, will fall to the bottom. Within about 2 hours, the next layer up, silt, will have settled on top of that. And here is the part almost nobody has the patience for. The finest particles, the clay, can take anywhere from 24 to 48 hours to fully settle out, forming a thin, distinct layer on top. When it's done, you have a visual cross-section of your soil's exact texture, layered like sediment in a canyon wall, because that is, structurally, exactly what it is. Measure the total depth of the settled soil, then measure each layer, and you can calculate your rough sand-silt-clay percentage, which tells you almost everything about how water moves through your ground, how roots will spread, and what it can and cannot grow well. A $180 lab test gives you almost this exact number. A jar gives it to you for free, and you get to watch it happen. The second test, the ribbon. While the jar is settling, there's a faster test you can do in about 90 seconds, one that tells you almost the same thing without the weight. Take a small handful of moist soil, not wet, not dry, just damp enough to hold together, and squeeze it firmly between your thumb and the side of your index finger, pushing it out slowly to form a ribbon. If it won't form a ribbon at all and just crumbles, you're looking at sandy soil. It drains fast, dries out fast, and needs more organic matter to hold water and nutrients. If it forms a ribbon that holds for an inch or two before breaking, you're in loam territory, the sweet spot most gardeners are chasing. If it forms a long, glossy, almost plastic-feeling ribbon that holds for 2 inches or more, you've got heavy clay, which holds water and nutrients well but drains poorly and compacts easily, which is exactly why so many raised beds built with topsoil from a truck end up waterlogged and lifeless by the second summer. 90 seconds. No shipping envelope required. Something worth sitting with for a moment. I am not going to tell you that agricultural extension offices are hiding this information on purpose. I don't believe there's a room somewhere with people plotting to keep gardeners dependent on mail-order kits. Nobody needed to plot anything. A private lab that processes your sample and sells you a custom fertilizer blend makes money. A 90-second ribbon test using soil you already own makes nobody any money at all. The market simply did what markets do. It built an entire industry around the version of soil testing that could be sold and let the free version quietly fall out of the conversation. That's not a conspiracy. That's just what happens to information that can't be turned into a product. The third test, counting what's alive under your feet. This is the test that actually changed the way I thought about my own garden, because it's not measuring chemistry. It's measuring life. Dig a hole roughly 1 foot by 1 foot and 1 foot deep and set the soil aside on a tarp. Then go through it by hand, breaking apart clumps, and count every earthworm you find. The Rodale Institute, which has run some of the longest continuously operating soil health field trials in the country, has published findings suggesting that healthy, biologically active farmland soil typically holds somewhere in the range of 10 or more earthworms per square foot in that top layer, while depleted or heavily tilled soil can drop to 1 or 2, sometimes none at all. Earthworms are not decoration. They are a walking, tunneling indicator species. Where they thrive, organic matter is breaking down properly, drainage channels are being built naturally, and the soil food web underneath your feet, the fungi, the bacteria, the microarthropods you'll never see, is almost certainly functioning. Where they're absent, something is wrong long before your plants show it on the surface. If you found the jar test tedious, this is the test that will actually change how you feel about your yard. There is something almost embarrassing about realizing you have gardened in the same 12 square feet for 6 years and never once looked at what was living underneath it. The fourth test, Where the water goes. Dig a hole about a foot deep and a foot wide again, if you don't already have one open. Fill it completely with water and let it drain fully. This first fill just saturates the surrounding soil, so ignore the timing on this part. Then fill it a second time, and this time, time it. Measure how many inches the water level drops per hour. Healthy, well-drained garden soil absorbs water at about 1 inch per hour. Faster drainage means sandy soil, which retains little water. Slower than ½ an inch indicates compacted clay. This type drowns roots in spring and cracks in dry summer. This test reveals more garden failures than sunlight, fertilizer, or seed variety. Roots fail from water issues, not nutrients. Most don't assess their water situation before troubleshooting. The fifth test, the screwdriver. Do this quick physical test before chemistry. It only takes 10 seconds. Take a long screwdriver and push it straight down into moist soil using steady pressure, not a hammer. In healthy soil, it should slide in fully with moderate pressure. If it stops at 2 or 3 inches, the ground is compacted. This means roots can't grow through it, even with fertilizer or water. It's a common reason gardens fail to thrive and easy to fix with broad forking, deep mulching, or tap-rooted cover crops like daikon radish. Agronomists recommend this test. Purdue's soil guidance suggests a penetrometer. However, a penetrometer costs $60 or $150, while a screwdriver is free. 5 tests take under 10 minutes, costing nothing. If you think your soil is a lost cause, if you've given up on your soil, whether it's clay or construction fill, stay with me. These tests guide you to fix issues instead of guessing solutions for years. The test. Most people never learn. This is the test used by Amos's grandmother. It provides a pH reading without needing a kit or lab sample. Take 2 soil samples, about 2 tablespoons each, in separate containers. Add ½ a cup of white vinegar to one. If it fizzes, your soil is alkaline. The fizz indicates higher pH levels. To the second sample, add distilled water to create mud, then add ½ a cup of baking soda. If it fizzes, your soil is acidic. If neither reacts, the soil is likely close to neutral, between 6.5 and 7.5. This method won't replace precision pH meters for commercial use. However, it quickly shows if you have alkaline soil or acidic soil, which affects what you plant. These tests are for home gardeners who want basic knowledge, not for every situation, such as heavy metal contamination. It matters that you understand soil beyond numbers. A farmer named Amos reminded me, "The numbers don't grow the plant. The dirt does." His words have stayed with me, emphasizing the knowledge we lose thinking only about data. This channel is about more than saving money. It's about retaining essential knowledge lost to modernization. If you've found value here, subscribe to keep this knowledge alive. Before you leave, when was the last time you touched your soil before planting? Be honest. Stay tuned for my next video on a method from Amos for storing vegetables without refrigeration, dating back to a 1923 agricultural bulletin.